So yeah, I had the pleasure yesterday to have a quick chat with Simon at the Make Build Faster with migrating over to Bazel breakout session, and he gave a lot of very useful advice on how to migrate to Bazel. So I'm really looking forward to his talk today, a linting framework for Bazel. Over to you, Simon.
Hi, my name is Simon Stewart, and I'm here to talk to you about a linting framework for Bazel that's recently been open sourced. Thank you very much for that introduction. I'm currently part of a build team, and we're focused on delivering wicked fast builds at scale. And we're using Bazel as part of the tooling to make that happen. Previously, I was a lead of the build tool team at Facebook, working on Buck. And before that, I was at Google, happily using Blaze, which is the progenitor of Bazel. I also happen to be the lead of the Selenium project, which uses Bazel as its primary build tool, and that explains the t-shirt. So before digging into the tool, let's set some context, starting with why lint at all? There are two primary reasons for running lint checks. The first is to ensure that code meets certain consistency standards, such as code formatting. The second major reason is for running lint checks is to perform some kind of static analysis of a code base, determining common problems. In the Java world, tools such as PMD and spot bugs are commonly used, and Bazel ships with error-prone configured in the default Java toolchains, as you've probably found out. For the sake of this talk, I'm going to assume that linting is a self-evident good thing. If it's not a self-evident good thing, then perhaps we should be having an entirely different discussion, and I'll be available in the water coolers later for us to talk about that. But that brings us to an obvious question. Why lint with Bazel? One of the key things my team is attempting to do is to ensure workflow parity with other build tools to help ease migration. Put another way, we never want to regress a developer's build experience when they move from whatever it is they're using at the moment to Bazel. And almost all build tools out there make it a breeze to add and run linters. For Gradle, it's as simple as pulling in a new plugin and some minimal configuration. For Go, things like Go format and Go vert are included as part of the default toolchain. Simple. We want things to be equally lightweight and simple for Bazel users. Integrating lint checks into a Bazel build without requiring any additional tooling helps us to achieve that workflow parity. It's really important for us in order to encourage adoption. So now we set some context and realize why we want to run lint checks within a Bazel build. I have a small confession to make. This talk has nothing to do with linting. It has everything to do with a lint framework. What's that? A lint framework is simply a consistent mechanism by which linters can be hooked into a build. It's a way for ruleset authors, for example, those for Java, Kotlin, Python, Rust, Go, Node.js, you name it, to surface functionality and additional useful capabilities for users to be able to discover these and take advantage of that. So perhaps it would be best, given that somewhat woolly description, if we laid out expectations for what we have about a linting framework. Well, the very first thing is it has to be opt-in. Nobody likes to have linting thrust upon them, particularly if their code doesn't meet the arbitrary linting standards that somebody has applied. So once linting has been introduced to a code base, it's also really useful to be able to opt out of it optionally. So perhaps we have some generated code that we want to avoid, or perhaps we have a package that is from a third party that doesn't follow the same coding conventions that we do. We want to be able to include that in our repo, but we don't want to include it in the standard linting checks. What we do want, however, is a shared configuration for linters across an entire repository. When you're looking at a small project, that makes sense, right? Like it's 1 or 2 people, 5 people, all sharing the same project, handful of targets. Of course, they're working on one thing, they have a consistent standard. But even if you're working on a mono repo with dozens of developers, hundreds of developers, loads of targets, hundreds of separate sub-projects, having consistent linting standards makes it easy to work across that entire code base without having to go, hang on, this is Sarah's team and they're doing things one way, and this is Pete's team and they're doing it another way. And this common code, I throw up my hands. I have no idea what I'm doing here. But even within that single repo, you want overrides on a per package basis. Again, that third-party code package that you're pulling in from someone else, you probably don't want to apply your linting standards to. The key thing here is it's got to be hard for a developer writing new build files to be able to forget to add the lint checks. I mean, we've all worked with devs. Most of us are developers ourselves. We're just too focused on solving the problem to also focus on making sure build files contain every last bell and whistle. In fact, if your developers are anything like the ones that I work with on a regular basis and have throughout my entire career, they're not interested in build files at all. Linting requirements. With these requirements in mind, let's consider some of the approaches I've heard or seen people try. I'm sure there are a few more options. I recently found out about a thing called validation actions that are embedded in Bazel itself, but the ones I present here will capture the meat of the available solutions. Firstly, we can consider just manually adding lint checks to each build file. There's a certain appealing simplicity to it, particularly when there aren't many build files and there's not too much to compile. I mean, you can't get easier to implement than just adding a new rule into a build file. However, it's equally easy to forget to add those lint checks. I mean, that's a real problem, right? Like if I wasn't aware that I was meant to add linter X, then I'm not going to write that test rule and linter X will never be applied. Oops. Worse, as more linters are added, build files rapidly become unwieldy. Like you want to be able to look at these things and go, look, I'm building this, not I'm building this and also these 15 dozen different linters. It's just a nightmare and a terrible thing. And Bazel's globbing behavior does tend to catch people out. And by that, I mean, most developers unfamiliar with Bazel will expect glob *** to recursively follow every single subdirectory and find every single file in the entire repository, rather than stopping at the Bazel package boundary. They need to be educated about this, and nobody wants to be educated in that way. The other really great advantage of manually adding the tests is you get really fine-grained control over which linters are run. You can choose, you add them, they run. One point to bear in mind is that at some point, someone is going to suggest using a macro to add all the required lint checks. Now that person is probably right. The second approach I've seen is one that's aspect driven, typified by something like Thundergulf's Bazel linting system. These solve the problem of a proliferation of build targets, and so solve the hard to forget issue. Your build files just become focused on the thing they're building, and you don't see anything about linting. However, they do so at the cost of an additional command line flag that needs to be added. You may be able to hide this in a .bazelrc, but the advice I've heard most frequently is to just use a wrapper script. The other problem with lint-based tests is that invoking a specific one from the command line can be tricky. People get comfortable with regular build targets very quickly, but add more cognitive load, such as, I don't know, whatever it is that makes an aspect run. I don't even know it, and I use Bazel every day, and it's not long until they don't bother to run the tests themselves and just let the CI system take the strain. Similarly, if you're using a wrapper script, that wrapper script needs to be the thing they're interacting with all the time, or they'll forget that it's there and your lint test won't be run. What a pain in the backside. Finally, there are Frankenstein monster solutions, which use a combination of bad ideas and a judicious sprinkling of magic to rewrite build files and add the tests in themselves. And let's all agree to never do that, because it's a terrible idea. So both the manual and the aspect-driven approaches have their advantages. Between them, they cover off every item of our requirements checklist. I mean, we should take a look at them, right? The good things from the manual tests. Tests appear in build files. You can do Bazel query, they're easy to find, they're discoverable, right? And that's a great thing, because it means that devs can quickly figure out how to run tests. And we want them to run the lint tests, right? Otherwise we wouldn't have them. It also takes minimal effort to omit generated code. That is, if you want to not run the lint test for this pile of code, you just don't add the test target. I'd suggest the disadvantage is that actually you need to remember to add the things, and that's difficult. But there are good things from aspect-derived tests. I mean, like it's equally hard to add them to a manual test. It's really hard to forget adding an aspect-derived test. It just happens for you. And these things are really easy to configure globally using a toolchain. And toolchains are a really useful way of approaching the problem, right? Because then you've got that consistent configuration for the entire repository. What would happen if we could somehow merge the two approaches? Let me introduce Apple Rules Lint. We've been using this at work, and it seems to be hitting the sweet spot between configurability and capability. Let's go into some detail. So what are the features of Apple Rules Lint? Well, it's configurable at the workspace level. It's also configurable at the package level, including overrides. So if you need to apply a particular different configuration for this subtree, easy to do. It exposes tests that users can run. You can run Bazel query, you can find a test, you can execute them. But it's really hard to forget to add lint tests. So your developers just need to write their build files to build the things they want to do, and it will work. Also, and a really compelling advantage in my mind, is that extending the range of lint tests requires minimal effort. So what's the UX of Apple Rules Lint? Now we know what it can do, maybe we should discuss how to use it, right? We're going to come at this from the two obvious directions. Firstly, as a developer consuming a build that uses Apple Rules Lint, and secondly, as a ruleset developer who wants to expose linters to users. This is how you get started as a user. The PI you see here is from when we added lint checks to the Selenium project. Selenium project uses Apple Rules Lint. For the sake of this discussion, it's safe to assume that someone has provided a spot bug test rule that we want to use. That someone, by the way, was me. That test rule makes use of a spot bugs config, and you can see us adding that config to the build now at the root of our Java tree. I think it's pretty readable and clear what's happening here, so I won't belabor the point, but I will point out that on line 44, we have the exclude filter. That's spotbugs exclude.xml. That's the same configuration file that you could share with Gradle, Maven, or any other build tool. The next step is to wire Apple Rules Lint into your workspace, like so. At work, we like to have all our rule sets follow this sort of two-step initialization pattern, but the key thing here is on line 27, where we have the call to lint setup. This is just wiring the well-known Java spotbugs name to point to the config that we added in the previous slide. Just as a toolchain is available to every rule, this lint setup configures the linter for the entire repo. As you can see, it's opt-in. If there's no lint config, there'll be no lint test created. If you don't call lint setup, don't worry. No linters will be configured and your build will continue just as it always has. Again, I mean, we're serious when we say you need to opt in to linting. Now that's done, all we need to do is run the tests. We've set things up so that every single lint test is tagged with the keyword lint and with the name of the linter being used. So Java spotbugs in our example so far. This again is from the Selenium project. I'm looking to the right, by the way, because that's where the video is playing for me. So you'll see here that we're using test tag filters to only run the lint tests. And then we're taking advantage of the fact that the tests are in a part of the subtree. I would do it over the entire tree, but that would be incredibly boring and would probably be overkill for a demo, right? You can see here that these spotbugs tests are now all running. And there you have it. Executed 12 out of 12 tests and 12 of them pass. Clearly, Selenium is an exemplary code base. The nice thing here, it was just Bazel test. No fancy flags, no nothing. We just ran Bazel test. So That's how easy it is to use, but what are some of the other bits and pieces you can do with it? Here's an example of how you can override a lint config in a specific build file. You can use this to take advantage of extra linters that aren't configured globally, or to override an existing config for your particular package. This is very much like Bazel's own package rule. There's no name, and you just pass in the same kind of values that you do to lint setup in the workspace file. It's pretty lightweight, pretty simple. To be clear, provided you have Apple Rules lint loaded, even if the global configuration says not to run any linters, this allows packages to opt in to running a linter. This is one way you can approach adding linting incrementally to your build. Load the rule set, and then in each of the build files that you care about, add package lint config. I recommend against doing that, however, because it's really difficult to unwind it when you get to the desired state of everyone running lint checks. Instead, well, you can just omit tests. And you can omit test generation of lint tests, and this can be done in two different ways. The way you see here turns off all possible linters. No lint tests at all will be generated for this particular build target. That's a good thing, as this target here is consuming some source files that were generated by a tool from a JSON file, and there's no way I can make those generated sources meet my rigorous coding standards. That's a little bit too much of a blunt approach, and I think it is. You can disable specific linters by using a no well-known name tag. In the case we're following here, that would be no Java spot bugs. One of the nice things with using tags is that we can use Bazel query to find the targets in our tree that where we've disabled linting. Maybe we had to, I don't know, turn off a few targets when we were introducing Apple Rules lint to the tree, but over time, we do want everything to be linted properly. And in our copious free time, we can just find a target, clean it up as we go. Life is sweet. The other side of the coin is how ruleset authors can add support for Apple Rules lint to their own rulesets. At work, we've wrapped many of the existing rulesets with a layer of indirection, so we've been through this process ourselves. It's designed to be as minimally invasive as possible, but I'll be honest with you, it's not free. Nothing good in life is free. We need to expose the lint tests as regular test rules. Most linters have a command line implementation, so we typically wrap what's in a test rule that executes it, passing in the correct flags and collection of files. This is a key to allowing developers to have a target they can run Bazel test against. You can't Bazel test something that isn't a test rule. Typically, linters are at least minimally configurable. We want to expose those configuration options with their own rule. Here you can see we're adding a configuration for spot bugs. And the main thing it's doing is just pointing to the regular configuration file that the linter uses. Like I said before, this is the configuration file that everyone uses, Gradle, Maven, and I don't know, your command line execution. It's all fine, same file. Look, this is lightweight and painless here. And the nice thing is this entire configuration fits into a screen full of code that I can include on a slide. Hope you can read it okay. Now, we take a leaf out of the manual rule approach and we wrap the underlying rules in a macro. This example shows how we add spot bugs checks to both Java library and Java export. You can see the definitions down at the bottom of the file. Obviously, if there are no source files, there's nothing to lint, which is what we check on lines 13 and 14. The magic happens on line 18 here, the call to get lint config. We ask for the config by the linter's well-known name, and we pass in the tags. If the tags contain no lint or no well-known lint, and that's no Java spot bugs in this example, then this will return none. Similarly, if nothing is configured, none will also be returned. However, if there is a linter configured by lint setup in the workspace file and linting is enabled, whatever that key in the dictionary pointed to will be returned. In our case, it's a spot bugs config we saw earlier. If we see the linter config, then we generate the test targets. See, that person who suggested using a macro was right after all. Again, this mechanism for adding a lint check fits into a screen full of code. Of course, if we'd also added a lint test for something like check style, we'd add that to add lint tests and we'd no longer fit into a single screen, but that makes for a terrible talk, right? Because we've added the rules using a macro, a developer can find out the targets that can be run using just Bazel query. This means that your code can be linted. This also means, by the way, that your code can be linted as it's being compiled. If you've got a build grid handy, that'll help speed up the build. For rule set authors, the only thing they need to do is to declare a dependency on Apple Rules Lint, and then be sure to call ruleset lint setup in their own setup methods. So they've done everything else. They've set up the config, they've set up the test rule. This is the final step. In the case where lint setup has already been called, this call to ruleset lint setup will be a no-op. In all other cases, it will initialize the lint framework with an empty list of linters. Although these steps to add new linters seem involved, they need only be done by ruleset authors. However, if a team wants to add their own linters, they can use the same pattern to add custom or proprietary linters that the ruleset authors were unaware of. That's a really powerful capability. This is particularly useful for linters, which can run against many different languages. It's not always obvious where to put those engines. As an example, Facebook's infer engine can run against Java and C++. Super useful static analysis tool that finds null pointers and all sorts of problems in code. But would that live in Rules Java or Rules CC? Doesn't need to. It can live anywhere it wants to. So Apple Rules Lint is good, but it's not all good. There are some gotchas. The first of these is that test sizes and test durations need not align. Like the inputs to the test rules and the lint checks are just running locally, right? They seldom need to reach out to the network. They seldom need to do exciting things. They're technically small, right? But they can run for quite a long time, which may make them medium or large. That is, the test might be small, the lint check might be medium. Linting built-in rules, such as Java library, requires discipline with the build files. In the Selenium project, we need to make sure that we always pull in our own definition of Java library and not use the one that ships with Bazel itself. And if we don't do that, then what happens is the build still works, everything compiles, but we lose the lint checks, and that's suboptimal. Another important thing is that all these extra tests take time and can slow the build. I mean, that's true of any build tool, right? If you're doing more work, it'll take longer. At least here in the Bazel world, we're only going to rebuild the test tools, the lint tests, when the inputs change. And if you have a build grid available, it's not a problem, right? You just parallelize and life is sweet again. So how does Apple Rules Lint work? Well, the first thing it does is it checks for this Apple linters workspace. So this is done in the lint setup or the ruleset lint setup. This workspace contains a public dictionary of linter names to config targets. And rulesets load this dictionary and can add a dependency on the target. So that was the spot bugs config that you saw earlier. The first ruleset to call Apple Rules Lint's own setup function gets to write the dictionary. And that means that users should load their lint configs as early as possible. If they don't, there will be an error. So if they put their lint config at the bottom of their workspace file and they try and load it and something else has already configured things, then the lint framework will throw an error and will say like, hey, look, you probably need to move this up. We tried to make it user-friendly, but it's an inescapable way of the way that things work. What Apple Rules Lint isn't. It doesn't provide lint checks itself. It's a framework that can be shared by rule sets to enable adding lint checks. It doesn't automatically and magically add lint checks. Again, it's a framework that can be shared by rule sets to enable adding lint checks. And it's really not suitable for whole repo analysis, which is something that I've noticed that some people really like to do. It's best used for linting when the inputs are the inputs to the rule and the transitive dependencies of that rule, and that's all that's needed to lint correctly. And finally, probably most disappointingly, it won't rewrite code. That is, if a lint test fails, it doesn't necessarily rewrite that thing. But what you can do is you can use the same framework to add a fixed target. So that's what we've done with our Kotlin rules. And there's a set of PRs that are open on rules Kotlin, which I need to finish up, which add that capability. There's a lint test and a matching fixed test, so that If the lint test fails, you can run the fix and everything is good. Like to try out Apple Rules Lint for yourself, then please give it a whirl. It's been open sourced and you can find it here at github.com/apple/appleruleslint. If you need help with it, then please feel free to file issues or come and ping me. I'm on the Bazel Slack most of the time during British work hours, and I'd love to help get you started. I'd also like to thank everyone for your time and attention. Thank you. And I'd also like to thank the organisers of this event for giving me the opportunity to speak. Now, if I've judged this right, I hope there's some time for some Q&A.
Simon, thank you very much for the presentation. That was great, and I think we've got a lot of questions.
Good.
Here. So I think I'll get right down to it. I think the most popular one, and I think you partially answered this, but I'll repeat it. I'll repeat it anyway. Often linters can suggest auto fixes for lint warnings. Have you thought about how you might facilitate this in your framework?
I have thought about it, and the trick is to remember this is a framework for letting people basically add their own targets onto arbitrary build rules, right? And so what you do is, if you are generating a lint test, you also generate a fix rule at the same time. So I've added KT lint and KT fix to the Kotlin rules, for example. I need to finish those PRs up because there's a couple of things I need to do, but that's a way to do it. And then you've got to use Bazel run to execute those, because Bazel can't obviously edit things in its own tree when you're running Bazel test.
Makes sense. Makes sense. Okay. The next question: are you set on the name Apple Rules Lint? It looks to me to be Linting Rules for Apple Rules, which exists. Could it simply be Rules Lint and have a standard import of com Apple Rules Lint, if not com GitHub Apple Rules Lint?
Yeah, I'm not tied to it. I would need to talk to people at work to get the name changed, but I don't see that being necessarily a problem. Also, if this were to become something that was more widespread, we could then have a discussion with the community about where the best place to host this is. But it's
actually, I might just seek into kind of like a very closely related question, which was that how do we get more adoption of this? Like, is there a plan to get more rule set authors integrating with Apple Rules Lint?
I would love to see adoption of it. Like, we use this at work, and it is, like I said, it hits that sort of sweet spot between capability and configurability and simplicity, right? It would be nice. I have a set of PRs for, like I said, Rules Kotlin. I haven't finished landing those because I also have other things that I need to do during my paid work hours for some reason. It's disgraceful. I would also be happy to work with ruleset authors. Like, the main problem is that you need to separate the loading of your dependencies from where your setup is done. Like, and that's a fairly common pattern you find in rule sets all over the place, right? Where they go like, hey, look, my rule set deps, or deps.bazel, and you pull in all the dependencies, and then there's a second setup step once like all the transitive dependencies are available. I'd love to see greater adoption. Happy to work with people to make that happen.
That's great. That's great. Well, hopefully, I mean, there'll be a water cooler afterwards, and hopefully there'll be a few people joining that can maybe facilitate that.
Yeah, I'd be happy.
Yeah. So I think in terms of the next kind of question, which kind of like leads on to that, is how is language server IDE integration handled, if at all?
It's not. Like, we have the targets. Like, if there's a way of running the targets inside the IDE, then you're fine. I believe the validation actions that ship as part of Bazel itself are designed to handle this. So the validation actions are a set of additional actions that you output somehow that get executed when you pass in some magic flags. And then when the target is compiled, the actions are generated and everything is good. I actually quite like the approach we've taken in Apple Rules Lint, because when you can parallelize onto a build grid, you can then run the linting on a different node from the different worker to the compilation of the rules. So it parallelizes in a slightly different way. But both approaches are great.
having linting at the test level presumably means linting and failing builds are treated the same. Do you have a way to land a PR with lint warnings?
Not with lint warnings. I guess you could use a custom conflict flag to that your rules understand that would enable you to skip that check. Again, the Lint framework just goes like, here's a way of hooking in additional rules as we compile the stuff and we read the build files, right? And what you do in those test targets is entirely up to you. So you could add your own conflict flag to allow sort of forgiveness, if you will. The other thing to do is you just go, hey, look, there's a build that runs with -lint, test tag filters -lint, and then you omit all the lint tests. And you go like, this code compiles and everything works. And then the second step could be, okay, now I'm turning on lint and I'll just run the lint tests.
And the last question. So some linters, I think you've already partially answered this, but let me just give it a go. Some linters, such as vert, require a wider view of the world to perform linting, such as unused functions. Are you able to support these types of linters in an incremental fashion?
So the lint test rule is just a regular rule. You have a view of transitively everything that depends upon you, which is like one of the guarantees that Bazel gives you, right? If your linting can be done using that set of dependencies that you have, then yes, otherwise probably not. In which case you probably want the lint test rule to be higher up with the equivalent of wrapping a binary, for example, rather than the library rule. You just move the lint test higher up in the tree and it does more work when it does the work.
Okay, well, thank you very much for a really in-depth and interesting talk.
Thank you very much. I appreciate it.